Hello students. In this video we're going to look at the computer assignment dealing with simple multiple linear regression and then an ANOVA question. So this is the handout that you have on your course platform. It comes with data as well. The data looks like this. What we're going to do is go through linear regression. Questions 1 in this sheet here. Sorry, questions 1 and 2 and 3 deal with simple linear and multiple linear regression. So I'm going to just show you the process to do this and where you can find some of these key values that we need. So to run some of the Excel tools, what we need, and I'll provide another video on this as well, but we need under the data tab, we need is data analysis. So if you're using personal computer, if you don't have the data analysis there, what we do is go File, Options, Add in, click Go, and make sure that first one is checked, Analysis Tool Pack. If you're using an Apple computer, I believe it's under the Tools settings. We're going to run data analysis. The first question asks us to look at sales versus advertising. The second question has us looking at sales versus disposable income. And then question 3 has us looking at the 2 independent variables versus the 1 dependent variable. So under data analysis, we go into regression. We're going to highlight Y variable, sales, and then we're going to highlight advertising for question 1. Make sure we label it as, we include labels in there. Output range, I'm going to just show it on this first same page. Oops, my Y changed. H, let's change this to up here. So this is our output. We can make these a little easier to see. Prints off these lower and upper values twice. We don't need them, so we can't get rid of them. These values are changing. They're set to change. You'll have to do the copy-paste special process to make them, not change. But here we have some key values. So I'm just going to center these because I just like doing that. We can reduce the decimal place there. So once again, this is the R value. Here's the R squared value. We can look at our level of significance there. That's a key value. These ones are key. There's our test statistic. We can also find a critical value using the appropriate degrees of freedom. And here is our p-value for our the independent variable advertising. So we know that overall it's significant because the p-value, significance f, and this p-value are less than alpha at 5%. Note that in simple linear regression, these two values here are the same. And then there is the information we need for our slope and intercept to get that regression equation. Answering the question, is there a significant relationship between the two variables? And this would be the process. Now, to do it for the second question, when we are looking at sales versus disposable income, go back to data analysis, regression, basically just changing where the independent variable is, the X variable, and then we could run that. And we're just going to impose that over there. That's how we would do questions 1 and 2. Question 3 basically has us, let's turn to question 3 here, show you quickly, looking at sales versus both independent variables. So to do that, back to data analysis, regression, and for the X variables, we're going to highlight both of them. And let's just place it all there again. So we can reduce this. We we can reduce some of these in here as well, make it easier to read. We don't need the last two columns. So note that this p-value has, it's written in scientific notation. There's an E -0.05. Basically, that means we have to move the decimal 5 places to the left. If you don't like the scientific notation, you can go up here, General, and change it to the number system, and just add in a whole bunch of decimals. So there it is. Oops, let's add a few more decimals there. So here is our regression equation, intercept with the slope for each of these dependent, or both of these independent variables. We know it's significant. Overall, the overall model using advertising and disposable income to predict sales in a various location is significant, because this value here is really small. That value is less than 5%. We could find the critical value of F as well. We're familiar with that process. Part of question 3 is looking at determining if there's a significant relationship between with the individual independent variables. So for that, we're going to look at these p-values here. Let's just make that a little bigger there. Note that in multiple linear regression, the significance F is not the same as either one of these p-values for the independent variables. This significance F predicts the overall, or determines the overall significance of the model. We can look at advertising as one independent variable. The p-value is less than 5%, so that would indicate that advertising is has a significant role in this model. Disposable income, it is not less than 5%, so disposable income might not be a good predictor of sales for this example. So those are some of the values. Here's our test statistics. T values for the independent variables. We could go and find critical values as well using the t-distribution chart, using appropriate degrees of freedom. And we can compare the test statistic with the critical value to make the same decision. If we have the p-values, we can use the p-values to help us make the decision. So once again, if the p-value is less than 5%, we would reject the null hypotheses and basically state that the use of that independent variable, in this case advertising, has a significant role in predicting sales in this model. So let's look at question 4 and 5 in our assignment. Question 4 and 5, real estate developer considering investing in a shopping mall. 3 parcels of land are being evaluated. Of particular importance is the income in the area surrounding the proposed mall. So they took a random sample of 6 families. We're testing at 5%. And then, if the decision is to reject the null hypotheses, we continue on to question 5 to do the confidence interval approach. Now, for question 5, we're going to do question 5 regardless of the answer in question 4, just for practice. So this data is randomized. So these data values will change. So you do have to do that copy-paste special approach. But let's see where we can get the data analysis tools. We go into the data tab, data analysis, single factor, ANOVA, click OK. The input range, all the values, including the labels. Make sure we include labels in there. It has a value for alpha. Our question states that we're testing at 5%. So that's what we want there. We're going to basically show the output on the same page. There is our output. Let's center these numbers. Makes it a little easier to read. Let's reduce these a little bit. And these ones here. So we have, in total, we have 18 observations. We have 6 observations per area, so in total, we could do an auto sum there and find that there's 18 observations. The degrees of freedom, remember, is k minus 1. So we have 2 degrees of freedom. This also known as treatments, and this would be also known as errors. And it has n minus k degrees of freedom for the denominator. So 18 minus 3 gives us 15 degrees of freedom. So using the degrees of freedom and level of alpha, we can go back to our F distribution chart. Oh, let's change that. And we have 2 degrees of freedom in the numerator, and we have 15 degrees of freedom in the denominator. 3.89 is going to be our critical value. 2 and 15. Oh, not 12, sorry. There we go. 3.68. Looking at the wrong row here, or there, so let's go there. So 3.68 is our critical value. Our test statistic is given to us. So we can make the decision based on this test statistic value and the critical value to reject the null hypotheses if F is greater than a critical value. It is not, so our decision is do not reject the null hypotheses. Remember, in ANOVA analysis, the null hypothesis is that they are all equal. Alternate hypothesis is that they are different. Basically, we are not rejecting a null hypothesis, so we're left with the assumption that they are equal. We can also make this decision by looking at the p-value. P-value is 9.5%, 0.095. It is not less than 5% alpha, so likewise we would not reject the null hypotheses. Regardless of your decision, these numbers, as I said, are randomized. They will change. I mean, you'd have to do the copy-paste special, so everyone's going to be working on different data. Your data is not going to be similar to this. So regardless of your decision, you're going to go on to question 5, which is conduct a confidence interval for the difference between area 1 and area 3. So there's the average for area 1. There's the average for area 3. Standard practice is to put the higher average as population 1 and the lower average as population 2. You don't need to do that, but that's just a general rule of thumb. And carry out the confidence interval approach using those values and, of course, our sample sizes, which are the same. And this value here, let's just reduce that a little bit. This is our MSE value that we need in that confidence interval calculation. You'll need to find a critical value for t-value, I should say, for the confidence interval. It's based on alpha, 5% or 95% confidence interval with n minus k degrees of freedom. So 18 minus 3 gives us 15 degrees of freedom for that t-value, and then we compare these averages. So that shows you kind of a quick process of how to do things to look for this computer assignment.